Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on linear relationship and making predictions. This video will also include some practice problems. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. This is part 3 of this series, and we are picking up with another example. In this example, we'll make a scatter plot, correlation coefficient, find the evidence of a linear relationship, the regression line, the scatter plot with the regression line, and make a prediction using the regression line. Note the calculator must have your diagnostics on for the correlation coefficient to appear when you do the linear regression. So for exercise 2, we have a kitchen store chain sells mixers. Sales for the mixer and the cost data are recorded in the table below. When the cost of the mixer is $19, the number of mixers sold that month was 260, and the correlation is given along the line. So the cost of the mixers are $19, $19.50, $20, $20.50, $21, $21.50, $22, $22.50, $23, and $23.50. The number of mixers sold in a month is 260, 262, 215, 217, 219, 170, 200, 188, 150, and 136. First, we will make a scatter plot. You will want to pause here. Put your data in list 1 and list 2, cost of the mixer in list 1, the number of mixers sold into list 2, and pull up your scatter plot. We have a video that does this in more detail. We're just reviewing we're doing kind of an overview in this video, and this is the screenshot of that scatter plot. Part B asks us to find the correlation coefficient. Pause and try to find your correlation coefficient by bringing up your linear regression screen. And here is the linear regression screen. And the correlation coefficient is R, and that gives us an R of negative 0.9312. Part C says, is there evidence of a linear relationship, and explain how you know. Well, to explain and to determine it, we have 2 steps. The first is to look at the scatter plot. Looking at the scatter plot, the plot shows a linear trend. The second part is to look at our R value, and the R value is negative 0.9312, and we will want to take the absolute value of negative 0.9312 and get the absolute value of R equaling 0.9312. With n equaling 10 sets of paired data, our table value is 0.632. That then tells us that since the absolute value of R is greater than the table value, there is evidence of a linear relationship. We will now find the linear regression equation. The linear regression equation can be found from our linear regression screenshot and gives us y equals negative 25.8788 from the A. Whoops, I went by too fast, sorry. Plus the B of 751.6242. So we get y equals negative 25.8788, and I'm sorry, there should be an x here. She's left out the x. So that's y equals negative 25.8788x plus 751.6242. Now we'll make a scatter plot with the regression line. To do that, on the calculator, you should just make graph as long as you restored it in Y1. If you didn't store it in Y1, go to Y1, type in the equation, and then press graph, and you should get a screenshot that looks like this. And that's a scatter plot with the regression line. For F, we're going to use the regression line to predict the number of mixers sold in a month when the price is $20.25. Recall that our equation is y equals 2.1924x minus 45.7581. And we can type that. This is the screenshot of typing it in on the calculator. But remember, what we're doing is plugging 20.25 in place of the x. That gives us, and this is just so wrong. That is not the equation. I don't know where she got that equation. I'm apparently not paying attention, but that's not the equation. The equation should be y equals negative 25.8788x plus 751.6242. And when you plug 20.25, you'll get negative 25.8788x times 20.25 plus 751.6242. We could also use the calculator if it's stored in Y1 and use the prediction, which is Y1 parentheses 20.25, and the calculator will substitute in 20.25 for the x in our Y1 equation. Either case gives us 227, and since we want this to be a whole number, we really should round that up to 228 in both cases. Here are some exercises for you to try, and I will provide some of the answers to help you check to see if you are on track. Remember, if you are doing this for credit, you will need to show all your work. Thank you for watching, and as always, if you're a Walter State student, additional help can be found by coming to the Math Lab in MBSS room 222 here on the main campus.